Hi guys, Miss Green here. After some mixed reviews about my planetary wind belts Ed puzzle, I think this topic is a little easier to understand. Today we're going to talk about the seasons. So we drew this in class, but it's very important when we're looking at a chart like this to try and tackle it in the same way as always. Well, what we're looking at is which of Earth's movements. And revolution is one reason why the seasons exist. What is the other main reasons besides Earth's revolution around the sun that gives us the reason for the seasons? The Earth's tilt, and that is exactly what you want to focus on first. So we live in the northern hemisphere, so you want to always look for the North Pole at every single location. And then really at only one of these locations is the North Pole tilted towards the sun. Right here in purple, we see that the North Pole is tilted towards the sun. So that is the summer solstice. It is June 20th through the 22nd. Could be any one of those days. It kind of varies on the year. And the direct ray of sunlight from the sun is hitting the Tropic of Cancer. Now, the Tropic of Cancer is 23.5 degrees north. And that's going to be the most northern part that the sun is able to hit with a direct ray. When we mean a direct ray again, we mean this 90-degree angle with the Tropic of Cancer. Now, if you know that this is going to be summer, then it makes it easy. Where is our winter location? Our blue area right across 6 months, actually, in its path, in its revolution around the sun, is going to be the winter solstice. That's December 21st, 22nd, 23rd. And that direct ray hits the Tropic of Capricorn. The Tropic of Capricorn is 23.5 degrees south. So we have to be able to recognize those two locations. They're very important. That is, again, where the direct ray of sunlight is hitting the Earth and when the northern hemisphere is experiencing winter. Because here we see the northern hemisphere is pointed away from the sun. It is pointed towards the darkness, which means that we're going to be experiencing winter. Then you just follow the counterclockwise rotation, and we know that from winter to summer, we hit the spring or the vernal equinox, which is in March 20th. And then when we're going from summer to winter, we experience the fall or the autumnal equinox, which is September 21st, 22nd, 23rd. When we have the equinoxes, we know that the direct ray is going to be hitting the equator. So equator, equinox sound very similar. So our direct ray will be right on the equator. At the equinox, it means equal day and equal light. So every place on the planet is going to have 12 hours of daylight and 12 hours of nighttime. All right, let's practice some questions on these. Which two dates could all locations on Earth have equal hours of day and night? Well, equal hours, I know I want to think about the equinox. And if we use the chart that I just drew and that we drew in class together, then we know that March 21st and September 23rd are going to be our vernal and our autumnal equinoxes. In Maine, which day has the shortest duration of insolation? Well, when we say shortest duration of insolation, we mean the shortest amount of sunlight that day. Maine is in the northern hemisphere, so we can kind of consider it like Connecticut or the New York or anywhere that's in the northern hemisphere. And we know that for us in New York and everywhere else in the northern hemisphere that we have the shortest amount of sunlight on December 21st. That's our winter solstice. The diagrams below represent Earth's tilt on its axis on 4 different dates. The shaded portion represents the nighttime side of Earth. Which diagram best represents the day on which the longest duration of insolation occurs in New York State? Well, we know that the longest duration of insolation is going to be summer. And we know that we find summer in the northern hemisphere by looking for where the North Pole is tilted towards the sun. So that would be location B. I see the North Pole is tilted towards the sun. Which of these answers would show the winter solstice for New York State? If we were talking about the winter solstice, then we would be looking for where the North Pole is pointed away from the sun. So that would be A there. So taking a look at these two diagrams, we see that in one, the Earth's axis at the North Pole is tilted towards the sun's rays, and then in the other, the Earth's axis at the North Pole is tilted away from the sun. So we're looking at two different seasons. If I were to label this one A and this one B, then which one is which? So A is clearly going to be the summer solstice. We see our North Pole is tilted towards the sun, and B is going to be the winter solstice. We see our North Pole is tilted away from the sun. So everywhere in the northern hemisphere is going to be experiencing a little bit more daylight. The direct ray, we know that right angle is going to be hitting at the Tropic of Cancer because it's June 21st, that first day of summer, when on diagram B, we see the direct ray is going to be hitting at 23.5 degrees south. That's the Tropic of Capricorn. The reason why in the northern hemisphere we get more daylight in the summer is because there's actually a longer path in the sky. So you can see in this diagram below that summer has the longest path in the sky, which means that we are able to get more daylight. So in New York State on June 21st, we get 15 hours of daylight. In New York State on December 21st, the winter solstice, so diagram B, we would get the lowest amount of daylight that we get in New York, and that is 9 hours of daylight. So the diagram below indicates regions of daylight and darkness on Earth on the first day of summer in the northern hemisphere. 4 latitudes are labeled A, B, C, and D. At which latitude is the sun above the horizon for the least number of hours on the day shown? Now, this is kind of a tricky concept, but let's think about it, right? We know that if the sun is over here, based on the way that it's shaded, right? So we see that nighttime is on the other side. So we know that the sun is on the left-hand side of the Earth. And we know that it is the summer because we can see that our North Pole there is tilted towards the sun. So in summer, we know that at this point at A, how many hours of daylight does A get? North Pole. In the summer, on the summer solstice. 24 hours a day. The Earth is going to be rotating counterclockwise, and that's rotating right in the path of the sun. So the sun never sets. They get 24 hours of daylight right at the North Pole. So that's a ton. You can't get any higher than that. And then at B, they'll probably get just about the same. At C, that's a little closer to, I would say, the Tropic of Cancer, which is getting that direct ray of light from the sun. They should be getting a lot of hours of daylight. In this case, the answer would be D. D gets the least amount of hours of daylight because it is the lowest latitude. On this day, which location has the greatest number of hours of daylight? In this case, our answer is C, right at the South Pole, because for us in the Northern Hemisphere, this is going to be winter. So we know that the South Pole is going to be getting 24 hours of daylight. So that's the greatest amount of daylight that we can get. Final question, which diagram best represents the angle of the sun's rays received at location C on this noonday? Well, part of our drawing should have given that away, right? At C, it's getting a direct vertical ray of sunlight, vertical ray meaning a 90-degree angle of sunlight. All right, guys, that's it for now. We'll practice this in class. See you there.